Okay, so go ahead and go into Canvas and go to Modules in Lesson 1.3 and pull up these notes. We're going to not do all of it, but we're going to do a big chunk of it right now. And then when you're done taking notes, wherever we stop, you can go ahead and submit that, and then that's your homework for tonight. Okay, so now we're going to be in Lesson 1.3 describing quantitative data with numbers. And so we have some special ways to describe quantitative data. And one of them is through the mean, and another one is through the median for measuring center. So we're going to focus on the center. Sorry, I was trying to get all my pens and stuff to work. Okay, so let's talk about the mean first, and then we'll do the median second. So the mean of a distribution of quantitative data is the average of all the individual data values. And to find the mean, we're going to add all the values and divide by the total number of values, okay? And so this is kind of what it looks like in your book. Also on the formula sheet, you're gonna have this on the formula sheet too. So let's say that N is the number of observations, okay? So for example, if we were gonna add up the average amount of time of sleep everyone got last night in our class, then we would have, I think there's 21 students, so N would be 21. And so you have the observations are x1, x2, x3, all the way to xn. So it's not infinite, it does stop at n numbers. And so we want to find the average, we call that x bar. X bar is equal to, we take all the x1, x2, x all the way to xn and divide it by n. Okay, on your formula sheet, it's going to look like this, the summation of all the xi's all over n. Okay, so here we go. Let's do an example. Here are the data on the number of goals scored in 20 games played by the 2016 U.S. women's soccer team. Calculate the mean number of goals scored per game by the team. Show your work. All right, so you don't have to write all of the numbers out. You can do this. You can go x bar equals, so there's 5, 5, 1, 10. So you go 5 plus dot, 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 and then usually you'll list the last one. And we're told there were 20 games, so we're going to divide that number by 20. And you can go to your calculator and figure that out. And it's 3.15 goals. So the mean will have units. In this case, we're talking about the average amount of goals that the team scored. Okay, so the games in which the team scored 9 and 10 goals are possible outliers. So those are right here. We see those, 10 and 9. Everything else is a lot lower than that. So 10 and 9 could be possible outliers. So let's calculate the number of goals scored by per game in the other 18. So what do you notice? Okay, so without those 2 goals, we're going to go 5 plus all the way to 3. But we're going to divide by 18 now instead. So we end up getting 2.44 goals. Okay, so we notice that with the addition of 9 and 10 goals, it made our average go up quite a bit, 3.145 and 2.44 if we were going to compare those two numbers. And so having that 9 and 10 in there really made an effect on it. It changed the average, changed the mean of the number of goals. All right, so a statistic is a number that describes some characteristic of a sample. Okay, so this was just a sample of 20 games that were played. Maybe there were 40 games or 50 games or who knows how many games, but it was just a sample of the games that they played. Now a parameter is a number that describes some characteristic of a population. Population would be all the games that were played, okay? And an easy way to remember this is statistic starts with an S, and so does sample. And then parameter starts with a P, and so does population. And if we were going to talk about the sample mean, that's called X bar. The population mean is called mu, M-U. Okay, it's like kind of a cursive-y looking U, but that's pronounced mu, and that would be the average of the population. We don't have that number a lot of times. We usually use a sample, but sometimes we are given population. All right, so a statistical measure is resistant if it isn't sensitive to extreme values. And we say that the mean is not a resistant measure, okay? The mean is not resistant. That means that outliers 9 and 10 affect the mean, and we saw that in the example above, okay? Okay, so that's one way to measure center, and we usually use the mean when we have symmetric data. The median is going to be the middle of the distribution. It's the number such that about half the observations are smaller and about half are larger. Okay, so to find the median, you want to arrange the data values from smallest to largest. And if the number n of data values is odd, then the median is the middle value in the ordered list. So if I have 1, 3, 4, 7, 8, okay? That's an odd amount of numbers. There's 5 numbers, and so the middle would be the exact middle in the list. All right, and if the number of n of data values is even, then we're going to use the average of the 2 middle values. So if it's even, let's just go ahead and write those numbers. We'll go 1, 3, 4, 7, 8, and 10. Then we would go to the middle 2 numbers and find the average of 4 plus 7 over 2. Okay? All right, next page. So here we go. Find the median of the number of goals scored in 20 games played by the U.S. soccer team. All right, so what we want to do is we're going to go ahead and put them in order. And this is kind of tedious. Sometimes I like to give you data that's already in order. So let's see, we have 1, 2, 3, 4, 5, 6 ones. So 1, 2, 3, 4, 5, 6 ones. And twos, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then threes, let's see, 1, 2, 3. 1, 2, 3. We have A4, 3 5s, 1, 2, 3, and then 9, 10. All right, and so if we were going to find the number in the middle, we'd want to maybe count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so we would average these 2, which is just going to be 2. So the median is 2, okay? And that would be like, if we were going to describe this using center, we'd probably want to choose the median because that's typical of what happens. So there's some 1s, there's some 2s, there's some 3s. These 9 and 10 made our average go up to 3.15, which was a lot more than we would expect. We would probably expect them to score about 2 goals per game. So it's the typical measure here. All right, and then the median is a resistant measure of center. Okay, so if instead of 10 goals, let's say they made 50 goals that year, the median didn't change. It won't change, okay? It's resistant against this huge number. Now the average, if I had averaged it with 50 goals instead of 10, the average would go up a lot. All right, so which one do we use to describe center? Well, it's going to depend on the shape. Okay, we talked briefly about this, of the distribution and whether there are any outliers. So those are going to really affect the mean if the shape's not quite right or there are outliers. So roughly symmetric and no outliers, you can use either one. Usually we use the mean, but the median's fine too because they're going to be about the same number anyways. If it's strongly skewed, we'll use the median. And if there are outliers, we'll use the median. Okay, so take a look at these 3 dot plots down here. So this is the quiz scores out of 20 or something for a class. And we can tell that it's definitely skewed to the left. And the mean is right here, and it's getting pulled towards these really low numbers. The median is right here at 19, and that would be a better number to use. What's the typical amount, what's the typical that they scored on this quiz? When we wouldn't want to talk about the average because there's some low liars down here. We would talk about the median. So here the mean is less than the median. When we have a skewed to the left, then the mean gets pulled to the left. Now here you see this is highway fuel economy in miles per gallon, and this is a roughly symmetric graph. Okay, we've got a high and a low outlier, but they kind of balance each other out. And so the mean and the median are just about the same, 22.4, 22.4. So you could use either one if you were going to describe the center of that graph. And then finally this one over here, we see some outliers way over here to the right. This is skewed to the right. Think about your foot. There's your foot. Okay, skewed to the right. And in this case, the mean is bigger than the median because the mean is getting pulled towards this 9 and 10. And so the median's right here at 2, but the mean is over here at 3.15. Oh, where'd it go? Okay, here we go. Some students purchased pumpkins for a carving contest. And before the contest began, they weighed the pumpkins. And the weights in pounds are shown here along with a histogram of the data. So we're going to calculate the mean weight of the pumpkins. Okay, so make sure that you show some work when doing this. We're gonna go x bar equals 3.6 plus 4.0 plus dot, dot, dot. So I like to list the first couple and then the last one. And out of how many? Did it say how many there were? No, count them real quick. 23. 23 pumpkins. Okay, so we put all those numbers into our calculator and we go ahead and divide by 23 and we get 9.935 pounds. You can write LBS for pounds. Okay, it's the pumpkin weight. Now we want to find the median weights of the pumpkins. So we'd have to list them all in order and then find the middle value. I'm going to show you when we get to class on the block that we're going to put these numbers into L1, all these numbers into L1, and then you can go to sort list on your calculator and we can actually list them from smallest to greatest and then we can see it that way. So we'll do that. But if you list it all out and you found the middle value, so there's 23 pumpkins, so you'd want to count 11 each way and that middle one would be the number and it ends up being 6.6 pounds. Okay, big difference between the mean and the median this time. So would you use the mean or the median to summarize the typical weight of a pumpkin in this contest? Well, it looks like we kind of have a little bit skewed, okay? We also have a couple of outliers possibly at 31 and 33. There's some small 36, 40, and then you get to these huge pumpkins. And so for me, I would want to use the median because the distribution of pumpkin weights, don't forget to use context. Anytime you explain, you don't want to say because it's skewed. Like you don't want to do that because the distribution of pumpkin weights is slightly skewed right with two possible outliers, and then you want to say what those outliers are, 31.0 and 33.0 pounds. Okay, so there you go. All right, next page. When are we gonna stop? Let me look. Yeah, we got a little ways to go. I'm not gonna do the calculator stuff with you because I want to do that in class and pull that up there. Okay, measuring variability now. Okay, so we know how to measure center. It's either the mean or the median, depending on shape and outliers. And we're going to measure the variability. And the variability, we have three different ways to measure variability. We can do range, which we've already talked about. We can do standard deviation, which we haven't. And we can do the IQR, which we're going to talk about what that is. Okay, if we want to talk about the similarities in these two distributions right here. So this is the length of PVC pipe and there's a supplier A and a supplier B. And if we talked about similarities or differences, we'd want to address SOVC when doing this. And we'd want to say this all in context, of course, but we're just going to list them out real quick without the context and stuff. So let's see what the similarities are. Shape. Yeah, I would say the shape is similar because they're both roughly symmetric and single peaked. Roughly symmetric and single peak. The first one has a larger peak, of course, The second one kind of has a peak like that, but it has a peak. Okay. Another thing that I would say would be is that they share the same center. Okay, so their center looks to be about 600 millimeters. Okay, and I kind of do like a little squiggly because I don't know exactly what it is. And I could put it in my calculator and figure it out, but I'm not going to. All right, let me get rid of these things here. Nope, I can't. How come? Oh, there we go. Yeah, I don't want those all drawn on my graph. Okay. All right, now how about some differences? Well, you can see here that supplier B has a lot of different sizes of pipe when A only has, just a small amount of sizes. And so the variability is very different for these two. So the variability for A is very sample A, or let's go with sample B. Let's say sample B or supplier B is more spread out. And supplier A seems to be more consistent, okay, in their length of their PVC pipe. And then any outliers, there's really no outliers, so we could probably say that's a similarity, is that they don't have any outliers, but we don't need to worry about that right now. Okay, now the range of a distribution is the distance between the max value and the minimum value, okay? That is that the range is equal to max minus min. We've discussed this a little bit too already. So find the range of the number of goals scored in 20 games played by the 2016 U.S. soccer team. So the maximum was 10, and the minimum number of goals was 1 in those samples, the 20 samples. And so that would be 9 goals would be the range. Now note, and I've talked about this already before too, the range of a data set is a single number, okay? The range is 9, the range is 15, the range is 20, okay? So the range is, okay? And the range is not a resistant measure of variability, okay? So if the number of goals was 1, and then instead of 10, remember we replaced that with 50 instead, then the range would be 50 minus 1, or 49. That's a big difference than a range of 9. So it's not a resistant measure of variability. It's not resistant to outliers and strong, large numbers that aren't typical. Okay, now, so that's range, and everyone feels pretty comfortable with that one when describing variability. The range is blah, and you can just, you can come up here and you can even look, the range for this one is this number minus that number, and the range for this one, so you can see how much spread apart the data values are. Okay, so the standard deviation measures the typical distance of the values in a distribution from the mean, not the median, but from the mean. Okay, so if it is calculated by finding an average of the squared deviations and then taking the squared root. Okay, this might sound kind of weird at first. We're going to talk about this. The average squared deviation is called the variance. Okay, and if the values in a data set are x1, x2 to xn, the sample variance, and we call this S sub x squared, is given by this formula. Here's the sample variance. S sub x squared is equal to, what you do is you take each data value, you subtract the mean for all the data values, and you square that number. And you're going to do that for each of them. x2 all the way to xn. Okay, and then we're going to take all of those numbers and divide it by n minus 1. Now, we don't know the reason why yet, and that's okay. We're just going to accept that it's n minus 1. We will one day talk about why. It has to do with degrees of freedom and stuff like that, but we don't know that yet. Okay. Okay, so that is the variance. Okay, this is the variance. Now, how do we find the sample standard deviation? Sample standard deviation is called S sub x. and it's the square root of the variance. So we have to take, basically you have to take the square root of this whole thing. Okay, I'm gonna undo that. How do I undo that? There we go. Yes. Okay. So here's how we write it. The standard deviation is equal to the square root of, and we're adding up the summation of all the xi's, x1, x2, x3, x4, all the way to xn, minus x bar squared, and we divide by n minus 1. Okay, this is on your formula sheet. It's down here. Oops, it's down here on your formula sheet. It looks like this. Okay, they just brought, the n minus 1 out front, but it's the exact same thing. And then your calculator also will be able to get a standard deviation for you. So you're not gonna have to do this by hand. Maybe we'll do it once by hand just to see it. And then they're gonna ask you to interpret the standard deviation in words. And so you're gonna say the context typically varies by whatever the standard deviation is from the mean of whatever the mean is, okay? And you'll see one when we do one in just a minute, what that little template does. Okay, let's go on. Let's see, I think we're gonna do 2 more pages, so just hang in there. Okay, let's do a big old example. Here we go. 11 high school students were asked how many close friends do they have? And here are their responses along with a dot plot. Calculate the sample standard deviation by hand and interpret this value. So here we go. I'm gonna walk you through this, okay? Like I said, a lot of times you're not gonna have to find this by hand. So the first thing we have to do is number 1 over here, first dot, find the mean of the distribution. Okay, so the mean of the distribution is to take all these numbers up here of how many close friends everyone has, and we're going to divide this by 11 because there's 11 kids. And it turns out to be exactly 3. Okay, we're given nice numbers here. Okay, so here's what we want to do. We're going to list all of the xi's right here, and they're all listed in numerical order, which is kind of nice. 1, 2, 2, 2. 4 3s, 1, 2, 3, 4, 4, 4, 6. Okay, and then xi minus x bar. We'll do that in the next one. So we're going to do 1 minus 3, which is negative 2. And then let's take all the xi minus x bar and square those numbers. So negative 1 minus 3 is negative 2, and negative 2 squared is 4. Okay, let's do 2's. We'll go 2 minus 3 is negative 1. Negative 1 squared is 1. There are 3 of those. And then the 3's. 3 minus 3 is 0. 0 squared. 1, 2, 3, 4. And then, 4 minus 3 is 1. 1 squared is 1. And then 6 minus 3 is 3. 3 squared is 9. And we add all those up, 9 plus 1 plus 1 plus 4, and we get 18. Okay? And then we're going to do, so square each of the deviations, we did that. Add all the squared deviations, then divide by n minus 1. That's really weird to get the sample variance. So then we need to divide by 10, right? N minus 1. So I have in my paper that I'm dividing by 11, but that's not right. And so we get that the sum of all of those, so I think I did it wrong when I did it earlier. I could pause the video, but I don't want to waste your time. All right, 1.8, so it's 18 divided by 10. Yeah, I just have it written down wrong on my paper. Okay, so this would be the square of the deviations. Okay, so we're going to divide by n minus 1, and then we're going to take the square root to get our standard deviation. Square root of 1.8, and that is 1.34. Excuse me. Close friends. Close friends. Okay, so that's what the standard deviation. Close friends. And then does it ask to interpret it here? We probably should though. So if we're going to interpret it, we would go to that interpretation, which is on the other page, which says, is it at the top, bottom? There it is. the context, so the number of close friends, let's write it over here. The number of close friends, okay, that's the context, typically varies by 1.34 friends from the mean of 3 friends. You could say close friends, I'm just using friends here, okay? So that's how you do it by hand. And then it says check your solution using your calculator. I'm not on my computer right now because it's not working today. It's Sunday and Mr. Parsons didn't email me back because it's Sunday. So I'm doing this on my iPad, but I can't pull up my calculator, unfortunately. But to check your solutions on your calculator, let's do this. Maybe I could walk you through this. If not, we'll do it in class. You'll go to L1. Okay, so go to Stat, Edit. So go to Stat, Edit, and then you'd put these 11 numbers in your calculator, and then you would go to Stat, again, over to Calc, and it's the first one variable statistics. Let's do this together in class. We'll have time on the block. Okay. The standard deviation is always greater than or equal to 0. It's never going to be a negative number. It's because when you take the difference and then you square it, and then at the very end we square root it to bring it back, that's why it's not going to be a negative number. Also, the reason why we square it is because when we're talking about the distance, if we were just to add all these up, we would just get 0 because all the distances would be the same from the mean, and you want to have positive distances to add, but then you have to take the square root at the end. All right, Sx is equal to 0 only when there is no variability. Only when there's no variabilities. That is when all the values in the distribution are exactly the same. Very boring. We're not going to have that. All right, larger values of the standard deviation indicate greater variation from the mean of a distribution. And if we were to go up here and let's say this person, instead of 6, she said she had 16 close friends. Okay, that's going to change this number over here by a lot, which changes everything by a lot. And so the standard deviation of a sample is not a resistant measure of variability. And then Sx measures variation about the mean. Don't forget it's about the mean, and it should be only used when the mean is chosen. So we're talking about roughly symmetric with no outliers. Okay, so they go together. When you want to talk about center as the mean, then you'll talk about the standard deviation. Okay, what if a 12th high school student was added to the sample who had 3 close friends? And that was the mean, remember, that was the mean. And so it says the mean number of close friends was 3. How would our standard deviation be affected? Well, when something is added, like a data point is added and it's very close to the mean or is the mean, then our standard deviation will decrease because our variability has decreased because that 3 is the mean. It's close to the mean, okay? And you could say it this way. The 12th value is at a distance of 0. Okay, it's at a distance of 0. And so if I was going to take and find the standard deviation, then I would take 18. So because this won't change up here, because I'm just adding another 0. So this number right here wouldn't change. But now instead of dividing by 10, I'm dividing by 11 because that's 12 minus 1. And so we can do a quick on our calculator, and we would get 1.28 close friends. And what was it before? It was 1.34. So see, it went down. So the standard deviation will go down when you add numbers close to the mean or exactly the mean. And then it will go up if you add numbers, especially further numbers out. Okay, last part. Here we go. And we can avoid the impact of extreme values on our measure of variability by focusing on the middle of the distribution, and it's called the interquartile range, the IQR. It measures the variability in the middle half of the distribution. So what we're going to do is we're going to start by ordering the data values from smallest to largest, and then find the quartiles. Okay, we're going to talk about what quartiles are. The values that divide the distribution into 4 groups of roughly equal size. All right, so the first quartile is called Q1, and this lies 1/4. So they're called quartiles. Splits into 4, 1/4 of the way up the list. It's the median of the data values that are to the left of the median in an ordered list. So, like, let me see. Let's see. We have 1, 2, 5, 6, 10, 12, 13. Okay. And this is the median. All right. And if we were to look at the lower, then this would be broken up and this would be Q1 because it's the median of the left numbers. This would be Q3. Okay. The second quartile is the median. We don't call it Q2, we call it the median, which is halfway up the list. So we've already talked about the median. And then the third quartile, Q3, lies 3/4 of the way up the list. Okay, and then the interquartile range, the IQR, is the distance between the first and third quartiles of the distribution. And here's how you find it. IQR equals Q3 minus Q1. So you take Q3, here's 12 minus 2, so the interquartile range would be 10 on that one. Okay, and then here's an example. And I think we're going to stop here and we're going to do this one together in class because I want to show you some calculator stuff too. So thanks for doing this. You can submit the notes right here and we'll pick back up in class on the block. Bye.